In our customer requirements, we have the qualifiers, the warning system, that the system can detect the leak, and also the reliability, that is about the resolution of the detection. And in our differentiators, we have, for example, the most important is anomaly detection, that using a machine learning algorithm, we can detect the leakage.
Well, in order to start the model for the product, we had to first define a household to work on. Based on INEGI data and other statistics, we decided to create the model based on a 3-person family. Taking this into account, we built a fictionary house for 3 people and a routine for them. As you can see, we will be creating a model based on the living situation of a woman with 45 years old, a man with 47 years old, and a child with 13 years old. Now we can talk about the overview of the project. The whole process can be divided into 4 different sections. The first one being the construction of the pattern. This was performed making surveys, statistics, and also water inlet. After that, we have the domestic consumption model creation, in which the data will be created using randomness and also a SimScape simulation. And after the data is created, the anomaly detection process will be next, in which the demand pattern identification and the anomaly identification will be taking place, exploring the efficiency of different tools in MATLAB. Finally, the user visualization, that will be the real-time actual consumption, and also a warning function for the probability of leaks. In order to create a first pattern, we had to characterize each of the consumption of the elements in flow per minute. You can see that information on the left. After that, we also use the water distribution chart found on a water company in Tijuana, in the website of this water company. And also, finally, we use the normal distribution of the frequency of each of the activities based on a survey that we made. Here we have a first approach for the water consumption of the family in 1 week. In the x-axis, we have the minutes of the week, and in the y-axis, we have the flow per minute. As you may know, the SimScape has some modules for hydraulic system simulation. Some of the modules need different parameters, and one of them is the length of the pipeline. Therefore, we decided to create a CAD model of the house and put dimensions on it.
This is the circuit business case. It's a representation of our business case. It consists in 4 rooms, which are 2 bedrooms, 1 laundry, 1 kitchen, and we can see the little circuits that consume the water. In our morphologic matrix, we have the functions and the solutions, and we established 4 options to solve the problem. In the part matrix, we have the 4 options, and we found that the option 1 have the best score because can solve the functions in a better way. In the selection criteria, we compare the customer requirements with the solutions for the functions that we found, and in this table we put different scores for each solution. We add a little weight depending on the customer requirement, and in the end we got the total score for each solution, and in this way we could find the best solution for each function.
Here we show the patterns that are very useful to us. In both patterns, user data is obtained to see their normal water consumption and to determine a consumption pattern per user. The difference between these 2 patterns is that the one on the left has a more instantaneous alarm. So that means that as soon as it detects a usage pattern that is out of the ordinary, it alerts the user. In the other, there is a longer period where it should be seen that the meter continues to supply water in the form of a leak. If this occurs, an alert is sent to the users and the severity of the leak is indicated by the minimum amount of the usage during the given time period. Algorithms to detect leaks are used in both patents. In one, you have an instant alert when a leak is detected, while in the other, you must have a period of time where the leak is present, but analyze how large or severe the leak is.
For the simulation, we take into account the following points. First, we create a random family of 3 members with gender per simulation. It remains the same until the simulation ends. The consumption change based on some statistic data that we got from our research. The consumption behavior along the day varies, change in quantity. This is made randomly between a range. For example, it is known that a person go from 1 to 3 times to the bathroom. So each day, it's the random quantity that it's going to use is going to be between that range. The simulation is made on Simscape that belongs to Simulink package from MATLAB, and there is a validation that avoids the use of 2 members using the same host element at the same time. Our simulation, as we said before, was made on Simscape, but we also made a part in MATLAB script because we can add some complexity stuff, and the physics part was simulated in Simscape. Here you can see some results. That is kind of information of the PC where the simulation was run. Here you can see some results in form of charts. You can see how even with some random parameters, the behavior is very similar. You can see the likelihood between the first 2 plots that was run in a very similar period of time, and it is important to say that each plot represents a totally different scenario and different amount of time simulated.
We had 3 options of possible time series algorithms: the AR, the IMA, and the RMAX. After all the analysis, we decided to use the AR algorithm, and because it suggests that the model of a past observation might predict current observations.
While outlier detection identifies data points that are significantly different from the rest of the data. The result obtained is presented below.
The outlier detection technique can be observed using quartile regression. Clearly, 2 limits are created, upper and lower, which will mark a normal flow band. An example is shown on the left, and the implementation on our system on the right. Note that it is combined with a smoothing technique. In order to improve the analysis of the data, it was decided to transform them in such a way that now we'll work on the accumulated sum of the data. The same smoothing and quartile regression techniques were applied. On the right, you can see a scenario that presents a small leak of 300 milliliters per minute. Note the slope of the blue graph that is formed from the leak detection.
We got to generate a set of rules that allow us to determine what the leak detection system should do when a certain condition is given. The rules obtained are knowledge, and to obtain this knowledge, some algorithm must be applied. Furthermore, it is essential to have a set of data that the algorithm can process to obtain the knowledge that takes us from a particular case to a general one, that is, generalization. Different algorithms were tested for this project, including AR, IMA, and AR Max. After all the analysis, we decided to use the AR algorithm. The AR model suggests that past observations might predict current observations. After applying the AR model to our dataset, the following graphs were obtained.
Our next steps are finishing the Simscape simulation, fit and prove the algorithms, assemble the Simscape model with the algorithms, and prove the solution designed.